This is an example of the quantifier exchange rule. We call it first class. The story is this. If anyone has a coach class ticket but there is no coach seat, then that passenger gets a first class ticket. Alice has a coach class ticket. Every coach seat is one that cannot be occupied by Alice. Thus, Alice gets a first class ticket. Let's begin by defining A to be Alice, C of X to mean X has a coach class ticket, O of X and Y to be person X may occupy seat Y, and F of X to mean X gets a first class ticket. The premises are these: for all X, C of X, and not there exists Y, such that O of X and Y, imply F of X. If anyone has a coach class ticket, but there is no coach seat, then that passenger gets a first class ticket. C of A, Alice has a coach class ticket. For all Y, not O of A and Y, every coach seat is one that cannot be occupied by Alice. The conclusion we seek is F of A. Alice gets a first class ticket. Once again, symbolically, the premises are for all X, C of X, and not there exists Y, such that O of X and Y imply F of X, C of A, and for all Y, not O of A and Y. The conclusion is F of A. So how would we construct a proof of this? Let's begin by looking at the conclusion. The conclusion is F of A. The first premise might yield us F of A if we were to instantiate the X to A. So idea number one is to instantiate the X to A. In premise one, there are two statements in the antecedent to F of A. The first of those statements would be C of A after the instantiation of X to A. That's good because it is our second premise. But what about the other statement in the antecedent? Not there exists Y, such that O of A and Y. How would we get it? The trick is to look at the third premise, which is precisely what we need were we to do a quantifier exchange. That is, for all Y, not O of A and Y is the same as not there exists Y, such that O of A and Y. So it appears that first by instantiating X to A, and then by doing quantifier exchange, we might get the conclusion that we seek. If you would like to complete this proof on your own, please pause this video now. We begin the proof by listing on line 1 the first premise, for all X, C of X, and not there exists Y, such that O of X and Y imply F of X. We want to instantiate the X to A, so on line 2 we have C of A, and not there exists a Y, such that O of A and Y imply F of A. Now let's put our second premise, C of A, down on line 3. And on line 4, let's put the third premise, for all Y, not O of A and Y. Now let's do a quantifier exchange to line 4. That brings the not to the front and swaps the universal quantification to an existential quantification. Thus on line 5, we have exactly the antecedent that we need to use in line 2. So on line 6, let's place the conjunction of lines 3 and 5 to get C of A and not there exists Y, such that O of A and Y. Finally, from lines 2 and 6, with modus ponens, we get our conclusion F of A, which is written on line 7. That concludes the proof.